Hi everyone, today I'll be going over Codeforces round 873 div 2, and there's still like a little bit less than an hour left in the contest, but I figured since only like 36 people solved D, I'm just gonna go over A through C, because like I don't think I could solve D. And this contest is actually like a really good contest for me. I think like according to like some ratings like predictor thing, I'm gonna promote to pupil, which is really cool. And yeah, so overall I did pretty good. Solved A through C. And if you guys have any questions about like any of the explanations, you can like feel free to let me know in the comments and I can just go over it with you. And yeah, let's get started. Okay, so first problem, divisible array. So you're given a positive integer n, and then you have to find an array that is perfect. And so a perfect array is like all the elements in the perfect array are less than 1,000. Each element of the array is divisible by its index, and the sum of all elements is divisible by n. And so you're like having to construct the array. So right off the bat, you can kind of see that for the case like 1, 2, and 3, like the array 1, 2, 3, where n is equal to 3. So the index for 1 is going to be 1, index for 2 is going to be 2, index for 3 is going to be 3. So let's write down I is equal to index. And then you can see that if you have the element, so like let's say this is your output, your answer, this would in fact work because 1 is divisible by 1, 2 is divisible by 2, 3 is divisible by 3, and the sum of 1, 2, and 3 is equal to 6, which is in fact divisible by 3. Or I guess I could write it like this: 3 divides 6. So that would work. But in the case where n is equal to 4, you can't use this pattern like too well, I think. Let's test it. So we know that all the indices divide, or sorry, all the elements divide the indices. So 1, 1, 2, 2, 3, 3, 4, 4, they're all divisible by each other. But let's check the sum now. So the sum of the array A is going to be 10, and that divided by 4 does not equal to 0. So this would not work. Okay, so now how do we construct the array? Well, we know that if we have the first element, so let's call the first element k. K can be any number, because even if you have like 1 billion, so 10 to the power of 9, in the ones place, and you have like 2, 3, 4, 5 in the other places, this is like the first element. This would always be divisible by its index 1. This is index 2, this is index 3, so on. And no matter what element k is, it could be a billion, it could be like 5, it could be anything, it will always be divisible by this number. So now that we have this observation, we know that we could put any number in the first index. Okay, so how do we solve this now? So we can construct the array as normal. So I'll leave like the ones place open. So we have 1, which is k, 2, 3, 4, so on to n, right? We can just do that. And then for k, we can put any number. So how do we solve for k? So that becomes like the actual problem. We could break it down to like what k equals. So we know that k plus the sum of the rest of the numbers. All right, so let's say given the problem, let's break it down to like a small test case. From n is equal to 3, we know that the answer will be k 2, 3, right? Because 2 is divisible by 2, 3 is divisible by 3, the index 3 and the index 2, and the sum of k plus 2 plus 3 can be divisible by n. You just need to find k. right? So how do we do this? So we know that k plus the sum of 2 and 3, so this is going to be 5. So k plus 5 mod 3 is going to be equal to 0. So that just means that 3 divides k plus sum, or let's just write 5. And then you can also rewrite this to say k mod 3 plus sum mod 3. So, sorry, actually, let me put brackets just so it makes it easier to read. Plus 5 mod 3 is going to equal to 3. Okay, so let's write this out. So k mod 3 plus 2, because 5 mod 3 is equal to 2, is going to equal to 3, right? And then after that, we can just subtract 2 from both sides. So k mod 3 is equal to, mod 3 is equal to 1. So that means that for any number k, as long as k mod 3 is equal to 1, then the answer will be correct. So you can choose any k, right? But so for example, k could be 1, right? K could equal to 1. Let me write it to the side over here, sorry. K can equal to 1. It could also equal to 4. And we can see that if we have a multiple m of n, as long as, a multiple of k, so like a multiple m times k, as long as it's divisible, or as long as that number, so like this product m times k, any multiple of k modded by 3 is equal to 1, then our answer will be correct. So this could also be like 7, it could be 11, and so on. But yeah, we could just choose like the first number where it works, so it's just 1, which is just like this answer. So now let me get into the code. So for each test case, I insert n, and then I calculate the sum of 2 all the way till n, and then I just subtract the sum and like modded by n, or sorry, the difference of n and the sum modded by n. So that will give you this answer over here, which is in this case 1. And then I output that, and then for each 2 to n, I just output like that number, and that'll give you the correct answer. Okay, moving on to question B, permutation swap. So you're given an unsorted permutation, and then your goal is to find 2 integers, I and j, such that the distance from I and j is equal to exactly k, and then swap the 2 elements at those indices, right? So what's the maximum value of k you can choose in order to sort the permutation? So let's write this down. Let me use the third test case over here. I'm gonna highlight it real quick. So let's say 4, 2, 6, 7, 5, 3, 1. Hold on, let me delete this real quick. Okay, so if n is equal to 7, and you're given the unsorted permutation. So first of all, a permutation, let me explain, is an array of elements from 1 to n exactly, without any duplicates, and so one of each element from 1 to n. So it could be 1, 2, 3, 4. It could be 2, 3, 4, 1. Sometimes the problems at Codeforces give you like a sorted permutation, which would be this case, but other times they'll give you unsorted, and like such as like the problem we're doing right now, where it's like 2, 3, 4, 1 in a random order. And so in both cases, these are permutations of length 4. So that's like how it could be described. Anyway, back to the problem. So given an unsorted permutation, in this case 4, 2, 6, 7, 5, 3, 1, 4, 2. Okay, so your goal is to find out what's the largest number k. So k is like a mystery. We'll have to find k, and then your goal is to find out like the largest k such that you can choose two indices. Like let's say 1 and 2, 3. Let's say right here. So this is index 1. So 4 is index 1 and 7 is index 4. And 4 minus 1 is equal to 3. Sorry. So the absolute value of the difference is equal to 3. So right now k is equal to 3 because we can swap 4 into its correct position. So the goal is to sort this array. And to sort it, we have to get all the elements into the right position. So 1 has to go here in the first index, 2 has to go here, all the way till 7 goes into its respective index, right? So how do we do this? Well, we know that for each element of the permutation, it can only go, if k is like a set number, it can only go k like distance away. So 4 we know has to go into this index right here, right? So that like the distance is equal to 3, right? Because this is 1 jump, 2 jump, 3 jumps. So that's 3 total jumps. And it can't go anywhere else. So if k is equal to 3, which is what we have in our answer right here, so k is equal to 3 is the output, we know that it can move only exactly 3 distances apart. So it can, so 4, the element 4 can go to 7, and another 4 distance apart is 1, 2, 3, right here, this element. So we know that 4 can move to 7, or it could also move to 1, right? Because they're both 3 distances apart. Let's check another number. Let's say 2. 2 is already in its right index because like this is index 2 and the element 2 is already in it, so we don't have to move that. But theoretically, it could move to 1, 2, 3. It can move to this index, and we could swap it. So the array, the permutation could be 4, so on to 2, 3. You could swap these two, right? But why would we? Because 2 is already in its correct index. And we know that the worst case, k could be 1. So no matter what, like the worst case, k is equal to 1, because we could always swap neighboring pairs, right? That's like a fairly common sorting algorithm, although like super slow, you could always do that. So say like k is equal to 1, worst case, we can just take this 1, travel one step, one step, one step, one step, one step, one step, all the way there, and like sorting it along the way. I'm pretty sure that's called like a bubble sort, but correct me if I'm wrong. And then 1 goes here, and along the way it like pushes things like back. So we know that worst case k is always equal to 1, right? So now we have to find the maximum k. So how do we do that? Well, we know that each element has to go to its like index, and then so in order to do that, you have to find out like the common denominator of all of them. So say 4 has to go to like the index 4, so it has to swap with 7. Then we know that 7 goes here, 2, oh sorry. So 4 distance from 7 is going to be 3. 2's distance from itself is going to be 0. 6's distance from 6 is going to be 1, 2, 3. 7's distance from Sorry, let me read something. Okay, yeah. Alright, and then 7's distance is also going to be 3, because like this is index 7 and it jumps 1, 2, 3 times. So that's going to be 3. 5 is going to be already sorted because it's index 5. 0 and 3 goes 1, 2, 3 times into index 3. 1 jumps 1, 2, 3, 4, 5, 6 times. And then so you realize that we can see a pattern here, right? So 4 can only get to indices where it's like divisible by 3, or where the distance is divisible by 3. 2 can only go to distances divisible by 0. And then so if you take the GCD of all these numbers, you end up getting 3. Okay, so now let me go over the code. So I input the permutations, and then I create a vector, and then using the vector, I push back the distances from each permutation to its respective index that it's supposed to be in. And then for each element of the vector, I check the greatest common divisor. And to do that, I just initially set it to the first element of the vector, which is like the distance from, in this case, the first element is going to be 4. So the distance from 4 to its index is going to be 3. So I start off with answer is equal to 3, because it's this number, which is the distance from 4 all the way till the index 4. So index 1 all the way till the index 4. And then I loop through all the GCDs, or all the elements of vector v, and then calculate the GCD of it using the GCD function, and then I output answer. Okay. Moving on to question C. So you're given two arrays A and B, and then your goal is to like find out the number of ways to reorder A such that all the elements of A sub I, or no, sorry, all the A sub i's are greater than B sub I. Right? And then you're also told that all the elements of A are pairwise distinct, meaning that there are no repeats in A. Okay, so let's say we're using the first test case, right? So 9684552. Let me erase this real quick. How do we solve this? Well, 9684552. So n is equal to 6. A is equal to, so the array A, 9, 6, 8, 5, 4, 2, 4, 1, 5, 6, 3, 1. 4, 1, 5, 3, 6, 1. Okay, so how many ways can we reorder the array A, so this array, such that all the elements of A sub I, so all A sub i's is greater than B sub I. So 9 is going to be greater than 4, 6 is greater than 1, 8 is greater than 5, 5 is greater than 3. But wait, 4 is not greater than 6. So this would not count as one of the ways to reorder it. So we have to find other ways to reorder it. And then we can see that the expected answer is going to be 32. 32. And so how do we get 32? So let's work a little bit backwards. So first off, we can see that sorting it probably will help, right? Because we want to see how many elements are greater than like its respective index in the other array. So let's just sort it to see what happens. So after sorting it, A now becomes 2, 4, 5, 6, 8, 9. B becomes 1, 1, 3, 4, 5, 6. Okay. So how many ways can the element 2 be greater than b sub I? Well, we know that 2 is greater than 1 and 2 is greater than 1, but is not greater than 3. So we cannot take 3, we have to only take the 2 ones. Okay, what about 4? We know that 4 is greater than all of these, not greater than 4, so we stop at 4. But the thing is, 2 already takes up one of the elements, right? 2 already takes up at least one of these. Or not at least, the 2 takes up exactly one element. So let's just say 2 takes up this element, right? So 2 and this element are paired up. Then that means 4 can only take this element over here. So 1 and 3. What about 5? Well, using the same principle as earlier, we can see that 5 can take up 3. It could take up 4, not 5. But it cannot take 1 or 1 because 2 and 4 already take it up, supposedly. Now we check 6. Same thing for 6. And now we're left with 8, 9, and 6. Wait. Sorry, so 2 takes up this, 4 takes up this, 5 takes up this, 6 takes up this. And yeah, so 8 can take up this. Okay, so how do we solve for this? Well, we know that 2 takes up 2 places. And we know that 4 takes up 3 places because it's greater than 3 elements in the array B. So we know that 4, the element 4, is greater than 3 elements in the array B, which is 1, 1, and 3. But we also know that 2, right here, takes up 1 element already because it needs to be paired with 1 element. So let's just say, out of arbitrarity, I don't know if that's a word, we can just arbitrarily say that it's the first element. So we know that these 2 are paired up. Then that means 4 can only take 2 elements instead of 3 because we subtract 1. So now instead of multiplying by 3, we multiply by 2. For 5, we do the same thing. We know that 2 takes up 1, 4 takes up 1. We could just say that arbitrarily. So now we know 5 takes up either 3 or 4 because it's greater than those 2. So now we multiply by 2. Now we check 6. We know that 5 is greater than 3, so it takes up exactly 1 element from B. And so from 6, we can choose 4 or 5 because it's greater than those 2. And then for 8 and 9, we know that both are greater than 6 and 5. So we can just multiply it by 2. And 2 times 2 times 2 times 2 times 2, or 2 to the 5th, is going to equal to 32, which is our target output. So that's correct. I think going over the code is going to make it easier, so I'm just going to go over the code while explaining it. And also, one thing we need to do and remember to do is to modulo the answer by 10 to the 9th plus 7, which is a common thing you see in Codeforces because the answer can get really large. Okay, so first I set up the modulo into a variable, so 10 to the 9th plus 7. I input the arrays A and B, and then I sort both of them to make it easier for myself later. And then I keep a index called index, and then I iterate through 0 all the way till n minus 1, so all the elements of the array all the elements of the array A. And then while A sub I is greater than B of index, then that means that, let me rewrite the case, 2, 4, 5, 6, 8, 9, 1, 1, 3, 4, 5, 6. At this point, I'm just calculating how many elements of B that A sub I is greater than. And then so in this case, it'll go all the way up to here. So right now it's going to equal to 2, so index is going to equal to 2, right? And then since it's equal to 2, I multiply answer by index minus previous. So I keep a previous array to see like where I left off, and then so like previous will basically increment every single time that I encounter like a new blob, I guess you can call it. So while it's greater than the elements of B and it's less than n, which means that it's within the array bounds, because I don't want to go out of bounds, then I add 1 to index, multiply it by answer, and answer is equal to 1 and not 0, because if you have answer set to 0, then answer times like any number, so 0 times any number, is always going to be 0, and you'll never get the right answer. So I set it to 1. I'm pretty sure that's like the identity like property of multiplication. Anyway, so I increment the previous, so that just means that I have to move on. So in this case where I is equal to 0, so while 2 is greater than 1 and 1, I keep incrementing it. So now index is equal to 2, previous, so 2 minus previous, which is 0 right now, is equal to 2, which pairs up with this answer. And then we increment previous by 1, so now prev is equal to 1. And then, so that just means that we can't use 2 and 1, right? Because they're already filled up. So now we're moving on to 4. 4 can go into 1 and 3, or 1 or 3. And then we calculate that by like increasing index again. And then we multiply that index, like the new index, minus the new previous. So now index is going to be 0, 1, 2, 3. So now we take 3 minus previous. So new previous is 1. So now that's equal to 2. That matches up with this. And then we keep going until n minus 1 is reached, right? So in this case, it'll be right here. We add that. Or we multiply answer with the difference of index and previous, and then along the way we always mod answer by the 10 to the 9th plus 7, just to make sure that it doesn't integer overflow, and then at the end we do the same thing and output the answer. Okay, so thank you so much for watching. If you have any questions, just feel free to let me know in the comments. I know it's a little confusing at times, and if you enjoyed it or if it was helpful, please like the video and subscribe, and thanks.